Welcome back to RNN Lab GH. Today I have prepared a very useful project for everyone starting out with basic electronics, our OHMIC-CALC, a portable Arduino based calculator designed to quickly solve the Ohm's law formula V equals IR. This is a foundational project, and to build it, we will use some familiar components with an optimized approach, 16:2 LCD display with the I2C interface. The I2C interface is crucial because it allows us to control the display using only 4 pins on the Arduino, saving us many digital connections. A 4x4 keypad matrix. We will use this keypad for inputting our values. This component is very efficient because it uses a minimum number of digital pins to read up to 16 different buttons. 3 additional buttons for selection and reset functions, and of course our breadboard, jumper wires, and the essential Arduino Uno. Now for the wiring. I have prepared an essential breadboard diagram. I recommend paying close attention to the video details, as we will connect everything very simply, step by step. Remember my rule for wires: red is always for positive power 5 volts or 3.3 volts, and black is always for the ground, the G and D. Did you see? Even though there are quite a few wires, the assembly is very simple. With the essential diagram I prepared for you, you cannot make a mistake. I took into account the Arduino pins, placing them in sequence in order to make everything very easy and accessible to everyone. Here we are, almost at the end of the assembly process. I want to show you a wiring mistake, made on purpose. As you can see, I connected the display and the I2C module on two different rows, separated by the central groove of the breadboard. This means they are not connected. This oversight prevents the circuit from working. Therefore, I urge you to always double check all connections before powering the circuit. Perfect. Once you have corrected the mistake and verified the connections, we can move to the computer to analyze and upload the code to our Arduino. One final detail on the project, I created a paper mask for the keypad. I colored the keys with the standard resistor colors. This makes entering the color code for Ohm's law extremely fast and intuitive. Here we are at the computer. We connect the USB cable between the Arduino and the PC, open the Arduino IDE and upload the code, which you will find in the description. This code is a bit more complex than usual and quite long. We will quickly look at it now. We don't have the time to explain all its functions in this video. If you're interested in an in-depth explanation of the code, write it in the comments. We will make a video entirely dedicated to Arduino programming and explaining the specific code. Now, let's verify our Arduino board and the correct serial port. This is another important point to check. Many errors or interruptions in the process are caused by forgetting to select the correct board and the serial port COM. The advice I want to give you is this: always check that the Arduino Uno is selected and that the port is the right one. Perfect. Now we upload the code, and afterward, we will go on to test the functioning of our OHMIC-CALC calculator. Here we are with our finished project, our OHMIC-CALC. Now let's test its operation, and you will see that it is much more than a simple gadget. It is an essential tool that can be extremely useful for small calculations and verifying mathematical formulas in the field of electronics. Let's start with the basic calculator. Thanks to our 4x4 keypad and the Arduino programming, we can quickly perform fundamental operations like addition, subtraction, and multiplication, very useful when you don't have a multimeter or smartphone readily available. Now, for the most interesting feature, calculating the ohmic value of resistors based on their colors. As we've seen, by typing the individual colors on the keypad using our mask and following the correct sequence, the LCD display will immediately return the resistance's ohmic value, eliminating the need to memorize all the bands. Our OHMIC-CALC supports the three most common configurations, 4, 5, and 6 bands. 4-band resistor. The first 3 bands determine the basic resistance value, while the 4th band is crucial because it indicates the tolerance. This is often gold plus or minus 5% or silver plus or minus 10%. This value tells us how much the nominal value of the resistor might vary from the actually measured value. 5-band resistor. In this case, we have 4 bands determining the value, and the 5th band is the tolerance. These 5-band resistors are considered precision components, as they have much tighter tolerances, often dropping to 1% or even less. They are ideal for circuits where accuracy is critical. 6-band resistor. This is the most comprehensive configuration. The first 4 bands determine the value, the 5th band indicates the percentage of tolerance, and the 6th band, which is very important data, indicates the temperature coefficient of operation. This coefficient expressed in ppm per degree C is crucial for professional applications, as it tells you how much the resistor's value will change for every degree of temperature variation. You have seen the power of this small, Arduino-based instrument. I hope you're inspired to build your own OHMIC-CALC and bring it to your lab. Did you see how simple it is to use this small instrument? The OHMIC-CALC is accessible to everyone, very affordable, and an excellent project for anyone wanting to start from scratch with basic electronics. It is extremely intuitive and fast. Once you learn how to use it, it will become an indispensable tool for your lab. I would love to know what you think in the comments, and if you would like to see another small, very useful lab instrument for electronics and Arduino projects. For the next video, I plan to propose a very useful project, an essential, versatile tool that no small electronics or Arduino lab should be without. Don't forget to leave a like if you enjoyed the video, and subscribe to the channel so you don't miss the next project. See you soon!